Okay, so here we go, 4.2. So first question. I don't know if you can read that. I couldn't make it bigger. It would have went off the screen. I'll read it for you. Total revenue, consumer electronics of 2000 approximated by the function. I'll write that out. I can't even see it very well. Where T corresponds to 2003 and FT is in billions of dollars. Find the revenue given the year. Okay. So basically this function here is f of t, that's a t, is 78.7 times, is that 1.1 to the t. That's a t up there. To the t, right? Let me. Okay, so that's correct. I've got it written out correct. Now, all right, y'all with me? Here's the key. This is just going to be a plug-in. Use your calculator, but there's one wrinkle, one trick, and they do this a lot in math science situations. Let me make you aware of it. Biology, chemistry, any economics, any kind of thing. They always do this. See what this says right here? T equals 3. T equals 3 is the year 2003. Get the idea? So T equals 4 would be the year 2004, and on you go, right? So the T number is the 2000 whatever. Okay, so what? Well, then in question A, they say, tell me about 2005. So what am I going to plug in for T? 5, exactly. They're just saying, hey, take T equals 5 and pop it in there. See what you get. So I will do that. Let's take T equals 5, put in 5. So part A will be, I don't even need the left side, 78.7 times 1.1 to the 5. You guys have your calculator? So my calculator would be 78.7 times 1.1 to the up arrow button, 5 equals. So I'll do it too. 78.7 times 0.1 to the 5. I'm getting 126. How many decimal places? 2. They say 2 places. Always look at the blue line. 2 places. 126.91 is what they want. Is that okay? Can you get that in your calculator? Any questions I can answer on that? Part B is going to be the same thing. Now, what's part C? The function remains accurate. What will be the revenue in 2014? Same thing. Yeah, so same thing. B and C, just plug in. I'll move on if you're okay. Let me know if you're... Please speak up. Are you guys going to be a quiet group? Please speak up. If there's anything I can help with. You probably help lots of other people have the same question. Anything confusing on that? Is that good?
I got 121. No, sorry. I got a different number.
Did you?
Yeah. I got 126.97. Yeah.
Maybe I messed up. Oh, wait, no, I did 8. I did mess up. No, I'm wrong. Yeah, no. I'm glad you spoke up. Yeah, I'm wrong. I typed in 78.8 on accident. Yeah, this isn't right. It should be 126.75. Yeah, I typed in the wrong thing on accident. Easy to do that. You know what? On tests, when I always took tests, I didn't want to mess up and get a lot of points off. So if I had a lot of button pushing on a problem, I would just do it twice. If I got the same answer twice, probably didn't mess up. But if you have 2 different answers, then slow down and go, okay, wait a minute. So it's a good idea. If you put in a lot of buttons, just do it twice. Good on that? Thank you for that. Here, quicker. These are the steeper ones. All right. So, first off, let me come down here. Here's the function they want. F of t equals y0 b to the t. So f of t equals y0 b to the t. Okay, so they're giving me, now I hope it's not confusing. Why y0? Let me talk about this part right here. This goes together. Y, you call it y naught or y sub 0. It's like a little knot down there, or y sub 0. Whenever they put a little 0 underneath it's called a subscript, right? Like submarine, it's low down. Whenever they put a little 0 at the bottom of a letter, what that means is at time 0. That means y value at time 0. In other words, at the start, initially, at the beginning of the whatever you're doing. So this means y at the start, at t equals 0. That's what that little 0 means. It's symbolism. They do that in all kinds of science, economics, biology, chemistry, everything. That's just, they put a little zero down there, they mean, hey, Y value at the start. So that's what I mean here. As you read this question, U.S. Census, blah, 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 increase from. That means that's the Y0, because that's the start. If something goes from this to something else, it started at the from, didn't it? That's the Y0 value. You with me? So they're telling me Y0 is 34.9. When they say from here to there, the from is the start, the Y0. Okay. In 2000, year 2000, to 94.2 in 2050. 2050. Okay. Yeah, that's not easy. And then what is there? And they want the function. Okay. Right. All right, so here's the deal. They're telling me the F is the number. So the 34.9 million, that's the Y0. And the 94.2 million, that goes over here because that's what it becomes. That's the function value in 2050 when t is 50. Why only 50? Why not 2050? Because that's 50 years after. 50 later. Let me slow down and let you digest that for a minute. Did you see what happened there? So in other words, this formula right here for population, okay, the F out here, and don't let, if the F confuses you, just call it Y, whatever. You know, or P for population, whatever you like. It's just whatever the population comes out to be, whatever letter you like. Don't let that throw you off. They're telling me that it went from 34.9, so that's my Y0, that's the start. The B, I don't know the B yet. I'm gonna find the B in a second. 50 years later, right, from 2000 to 2050, that's why time is 50. 50 years later, it became 94.2. Okay, so now I need to solve that little equation for B. Solve it for B. This is where it gets a little more challenging. So I'm bringing it over here. So 94.2. Well, here, let me start back here. How am I going to solve? B is, here's the equal sign. B is over here saying, I want to be alone. Get rid of all this stuff. Get rid of this 34.9. Get rid of this 50 so that I can be alone. Not easily done. First step, let's get rid of that 34.9. How are we going to get rid of that 34.9? Divided, huh? Because it's times. Yeah, perfect. So divide both sides by the 34.9. See if it comes out nice in our calculator. 94.2 divided by 34.9. No, it comes out ugly. So I'm just going to, you know what I'm going to do, guys? I'm just going to leave. Whenever I do a decimal that comes out super ugly, I just leave it as the fraction. I mean, it's better than writing out a million decimals, and we don't want to round. You don't want to round when you're still in the middle of a problem. Rounding at the end is fine, but I still have more steps to go. So it's best not to round. I'll just leave it. If I had divided it and it had come out nice, then great, but it didn't. On my calculator, it went on and on and on. The decimal did. So I'm just going to leave it. Now, here's the $1 million question. For all the money, now what? How do we get B alone? We're trying to find B. How do I get that 50 off of there? Can I divide the 50? No, it's not times. It's in the power. That's weird. How do you get rid of something in the power? What do we do? What? Oh, log? Log is when the letter's in the power. We'll do that in a little bit. Yeah, you 50th root it. Or another way it might, which way would be easier for you to think about? Maybe 1/50th power. Same thing as root. You're totally right, Joel. I'll just do 1/50th power. Same thing. That is a root, really, on both sides. That cancels it out. You do 1/50th power to both sides, which is the same as a 50th root, by the way. I don't know if you know that, but I just say do it this way. It might be easier to type in your calculator. So that's it. Type this into your calculator right here, and that'll be your B. So type in 94. Put parentheses divided by 34.9 to the power of 1 divided by 50 equals. Everybody see that? Maybe I should have written that out a little bigger. So, let me do it too. To the power. I'm getting 1.02. 1.020057. You guys getting that? And how many places they want? Round to the nearest, wait, use integers, round to 6 decimal places. Wow, they're not messing around. Oh, that's what I did, coincidentally. 6 decimal places. Are you guys getting that okay? On your calculator. So, that's the B. So what does that mean about the answer to this question? So that means the answer to this question, that's just the B, right? That's what goes right there. So then the function, f, is 34.9. That's still there. That's still the y0. B, now the B, I know, 1.020057 to the t, that's a t up there, power. That's the function. We could use that now to plug any time in and find out what the population will be at any point in time. That's an exponential population function now. Do you see what we did there? Yeah.
The 1 over 50.
Right.
How do you put that in?
To calculate it?
Yeah.
Just like this.
You just put 1 divided by 50.
Yep, just 1 divided by 50. But you got to put in parentheses, notice, because remember, whenever there's more than one thing in a zone, that's more than one number in the power zone, you got to put parentheses around that zone.
So the 150 over the B we don't touch.
Well, right, yeah, that's the right side. These canceled to just become plain B. That got B alone.
Oh, okay.
Yeah, that's like getting X alone or something. That's the B alone. That's, yeah, we're just doing the left side. And it's just literally this right here. But you need those parentheses. All those parentheses are needed. Because when you have more than one thing in a zone, you've got to parenthesize it. Right? 1 and 50 are together in the power zone. Parenthesize, tell the calculator it's all in the zone. Is that good? You guys able to get that? Because I think they have a, oh, that's all the part on that one. That's all that one.
If we were to square root the answer on the calculator, how would we do that?
If you're to root, yeah.
Not a square root on the calculator, but how would it come out? How would it look?
Yeah, you'd have to hit, I can show you afterwards if you want.
Yeah.
Yeah, I don't think it's going to be easy for you, but I can show you afterwards.
Okay.
Yeah. This is where you're going to really probably need to spend some time. All right, so notice right here, first and last data points. That means who cares about all this stuff in the middle? First and last. That's all I care about. First year, 1983. Last year, 1995. In the table. That's all I care about. First and last. Okay, and what do I do? They want me to do an exponential function. So just like the last one. Just like the last one. What was the last one? It was f of t is y0 b to the t. That'd be a good thing to put right on your 3x5 card. That's an exponential function for t, for time. Right? Remember, exponential means when the letter climbs into the power zone. See how the letter time has climbed into the power zone? That's an exponential function over time. So they're saying this is how the purchasing power of the dollar has grown over the years. So I'm going to take this real life data. This is very much how business people would really do this. They would take this real life data and turn it into an exponential function, which will basically fit that data. Really, I'm just doing the first and the last values in the table. Okay, so what does that mean, first and last value? Well, first off, where's y0? Notice I'm going from here to here, aren't I? So what's y0? 1.06. The time is 1983, but the y0, the initial purchasing power of the dollar, is 1.06. That's the y0. Good. Okay, B is always what you're going to try to find. Now you jump to the 2. How many years later from 1983 to 1995? That's 12 years, right? 12 years. 83 to 95? 12 years later. So that means time is 12. And during those 12 years, what became the purchasing power? 0.50. Went down. So the dollar was losing its power. You with me? That's the F of t. See the deal there? So this is the original y0. 12 years later, this is the F of t. So the original y0, time is 12 years later, there's F of t. That's exactly what I did in the last problem. You see what I mean? See what I started? They gave me from 34.9, that's the y0. The b is b. And then 2000 to 2050, that was 50 years. And the new value, 94.2, went right here. That's the F of t. See, that's the same kind of thing? Now you just solve for b. How do we solve that for b? Divide by that 1.06. Is that one clean? I'm going to use my calculator. I think that one might be clean. It's not. All right, I'm just going to leave it that way. It's kind of ugly decimal. I'll just leave it that way. So, good to there so far? Now what am I going to do? How do you turn that, how do you solve for normal b? How do you get b? How do you get that 12 off of there, in other words? 1/12 power. Both sides, though. Whatever you do on one side, you have no choice. It'll cancel out on the right side. See how that turns it into normal b? That's what I'm trying to find, is b alone. That gets b alone. Does everybody see that? And then the left side, hit the buttons on your calculator. I'm getting b equals something, 0.9. How many 6 decimal places. 0.939302. 0.939302. So I got b. We good? He's getting that okay? Now, let's go back to this function. This f is y0, which doesn't change. It's still 1.06. b, which is 0.939302, to the t power. Is that confusing? That's exactly what I did in the last one. Once you get your hands on b, put it back in the original function. Does everybody see that? So this is a function now. They're going to have me do one more step this time, though. But everybody good to there so far? So everybody says, all this work is exactly what I did last time. So they just say, okay, they gave me the y0, they gave me the 12 years and the new value, solve for b, put it back in next to the y0, but now just leave t. No, we're done with the 12 years or whatever, 12 years, just back to t. So this is the formula. That's the base, in other words, of the exponential. That's what the b stands for, base. Okay, so what? Now what is that? That is not what they want. They want even more this time. Now they're saying, okay, you got your formula, great. Tell us, when will the purchasing power of the dollar be 40 cents? See how it's going down? See how the purchasing power was $1.06, 84, 83, 73, 64, 57, 50. How long until it gets down to 40 cents? Sometime later, right? It's going down, down, down. If that pattern continues, that's what we're doing. We're using math to follow an exponential pattern. Very, very useful in the business world. So if that pattern continues, in what year will the purchasing power drop all the way down to 40 cents? Well, I've got this equation now, this formula. I can find that. How so? What do I do?
You put in 40 cents per F.
Exactly. You just put the 40 cents right there. You make it 0.40, right? 40 cents for F, right there. And then 1.06, 0.939, 302 to the T. That's right. And now I've got to solve that for t, which is far from easy. I'm going to go to fresh screen if you're okay with that. So this is, what number is this? I forgot what number this is. Whatever, I'm going to keep going. So what was it? 0.40 equals, what was it? 1.06. Oh, there it is. Number right here. 0.939. 0.939302. To the t. Okay. Now, how do you solve that equation? Well, first off, get rid of the 1.06 off the front. I'm just going to leave this as it is. Good to there? Here comes a super trick, which is what you were saying earlier with the log. It's log time now. When the letter is in the power zone, we're trying to find the time. We're trying to find t. When the letter is climbed up into the power zone, log both sides. So I'm going to come in here and I'm going to go log of this side, log of that side. That's a trick. I don't know if you remember that from Algebra 2. I suppose not. It's a pretty advanced trick. You've got to do log of both sides. And I don't know if you remember the log properties from algebra. Probably not, maybe, I'm assuming. There was some rules. Log of x over y is subtraction. Well, whatever. I'm not going to write all the properties out. There was this special property that said powers can come down to the front. Everybody see what happened there? That t dropped out of the power zone down to the front. That's gigantic, the fact that logs can do that. It just dethroned the t. It just dropped the t out of the power zone. Everybody see that? It just brought the t down. It dethroned. The t is no longer in power. That's what logs do. That's why we use logs. That's the great quality of a log. Only a log can do that. Can take something in the power zone and drop it down to the front like that. Does everybody see that? That makes sense? It dethroned it. It's out of power. It's not a threat. So now, why is that such a big deal? Because now it's easy to solve for. You know, back when t was up in power, like, how do you get that alone? Who knows? But now that it's in the base, it's no big deal. It's just times. Just divide by that whole log thing. And we're done. Just divide both sides by that whole log thing. Boom. T's alone. Hit the buttons on your calculator. You got to type all that in. Not easy, huh? Type all that into your calculator. I'm getting 15.56. Y'all getting that? Is anybody with me? Getting that okay? Am I doing this alone now? Am I starting to do the Charlie Brown teacher, the wah wah wah, wah wah wah, bunch of crazy symbols on the board? You tracking with me? Now, what is that 15.516? What is that? Well, remember what T was. T, remember this all started in 1983. And T is how many years after 83? Remember? So that's years after 1983. So you take 1983 and you add 15.56. What's that? 98.56. So 1998.56, that's why it's in the middle of the year. Now you might say, should I round that up? No, that means 0.5 means like halfway through. 1998 would be the beginning of 1990, like January. And 0.5 would be like halfway through, like June. So it's still in the year 1998. We don't want to round that up. It's not in the year 1999. Get the idea? That's just halfway through the year 98. So all they asked was the year. So we don't round it. We just say in the middle of the year 19, little past June of the year 1998 is when that dollar will shrink in value. If it continued with that pattern, then halfway through the year 1998, the dollar would be down to 40 cents in purchasing power. That was a lot of fancy math. Did you try? So all this part here was the same as the last problem, right? Just put in the Y0, 12 years later, put in the F. Solve for B, put it back into the original with the Y0, the B, and the T. And then they said, oh, now we want to know when it's 40 cents. So put 40 cents out here. And then that was the new stuff. So then we had the 40 cents. So I had to solve for the T, which is up in the power zone. So you divide both sides by 1.06. Take the log of both sides. The power drops down. That was huge. The power drops down. Then we were able to solve for it. We'll do this one. Okay. So it has been found that a worker, blah, 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 blah. P of T equals 23 minus 23e to the minus 0.2 T. P is how many items they produce. P stands for produce, like a new worker, how much they produce. How many items we produce in the first day? And what is T? T is the days. Or day number. Day number. T is day number, so. First day. Okay, so take that one. So they're asking how many on the first day? How many will they produce on the first day? So what do you do to answer how many are going to be produced on the first day? Plug in a 1. Because T is the day number. Day number 1. Plug in a 1. Hit the buttons on your calculator. We're out of time, though.